Together.
Alright, here comes some mood lining. Okay. Did I hit the... I did. See if you stay standing. Alright guys, just so you know, you are not going to see a problem like this ever, but we will be using decimals, percentages, fractions all over the damn place, right? That's basically what the probabilities are. There's a whole chapter on probability. And a huge part of statistics is the probability of things happening. So we're going to see a lot of decimals, a lot of percent, blah, 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 blah. Does anyone remember anything about... So for example, our number system, it's based on 10. I don't know why it's based on 10. So 10 fingers, right? So very logically, when we first started creating numbers, we started counting with things we had. There's actually a tribe, I think it was Papua New Guinea, that used to, that the name of the number was related to the body part as they counted up one side and down the other. It's kind of neat. So the toes, and they count the joints, and they count the joints, and they call it the... Anyway, more than you wanted to know, I'm sorry. So our number system is based on 10. Any fraction that has a bottom that's a multiple of 10 fits into our number system then. So for example, do you guys remember what, you see this up on the board, but what place is the 1 in?
Hundreds.
Hundreds. What place is the 2 in?
Tens.
Notice how I divide by 10 every step down, right?
Yeah.
So what place is this in?
Ones.
Yay, and then I divide 1 by 10 and I get
Tens.
tenths, hundredths, thousands. Notice that the place the number is in is equal to the number of zeros. Isn't the 6 in the third place? 1, 2, 3. Isn't there 3 zeros?
Yeah.
So if I had 0.006, that would be 6 thousandths. Everybody with me? Yeah, I like it. So what's wrong with 3/5 then? Does that fit into that? To be written as a decimal? No, right? Not yet. How do you change it so it is? Multiply by 2, right? If I multiply top and bottom by 2, what do I get? 6 tenths. So what is 6 tenths then? 0.6. Because the tenths place is the first place. So 0.6 or 6 tenths. Are you guys at all with me? Okay, so this would be 0.6. And then, here's the cool thing. What does the percent symbol mean? Out of 100, I love it. Per cent. Cent comes from Latin, centum, and you got 100 cents in a dollar, right? So cents is hundreds. So that means per 100. So this literally means 7 over 100. And that would be 0.07. You with me? So here's the shortcut. When I see a percent symbol, that means it has not been divided yet. Does that make sense? Percent means divided by 100. It hasn't been divided yet. So the percent number will always be bigger than the decimal number. Do you see that? Percent number 7, the decimal number is 0.07. Maybe? Maybe. Okay, now help me out. What happens to a number when you multiply it by 10? So like 8.3 times 10. Why is that easy?
83.
Yeah, what happens when you multiply by 10? You move the decimal over once, because again, our number system is based on 10, right? When I divide by 10, the decimal just moves back once. So if I divide by 100, that's 2 tens, I move it back twice. Whoop-de-doo. So when I'm changing decimals to percents or the other way, it's going to be move it twice, just which direction do I go? Everybody with me? The beautiful thing about that, decimal percent, write the letters in alphabetical order. If I'm going from decimal to percent, I go that way. If I'm going percent to decimal, I go that way. So let's see, 0.6, decimal to percent. I want to go that way twice. Once, what's here? 0. Twice, 60%. Everybody with me? Percents out of 100. 100 is 2 tens. Every 10 moves once, so that means I'm going to move twice. It's just a question of which way do I move. Yes? Maybe? Does this sound at all familiar? Some of you guys are still looking at me like you want to hurt me. I'm sorry. I'm just a messenger. Okay. So it literally is. If it is a percent, so this one, 42.7%. It's already a percent, so I'm going to move the decimals this way twice. That's it. Once, twice, so as a decimal, it's 0.427. Bam. And then what fraction is this? What place am I in? Tenths, hundredths, thousandths. So 427 thousandths. Okay, I like it. And again, everybody's got a very different math background in here. There's no reason to feel bad if you've forgotten some of this stuff, because if you don't use this, it's out your brain. The only reason I know math so well is because I'm teaching it every damn semester, right? And also because I love it, because I'm okay. So what about this guy? How do I change this? Let's do a fraction first. This will be nice and easy, right? What would this look like as a fraction?
64,000.
Good. Tenths, hundredths, thousands. 64 over 1,000. I don't care about reducing. Don't worry about that. Now, if I wanted to make it into a percent, again, how many times do I have to move the decimal? Which direction? Once, twice, to the right. 6.4%. Done. I like it. Okay, maybe. What about this guy? He's already a percent. How do I change it to a decimal? I got to move it twice. Which way? Left. So the poor little dude gets even smaller. Once, put a 0, twice. So 0.0003. Is everybody with me? 0.03%, stupid small. So the decimal is going to be even stupider smaller because it's divided by 100. What is that as a fraction?
3 over
10 thousandths. I love it. Don't say it too loud next to somebody or you just spit all over it. It's terrible. 10 thousandths. What about 1.12? Make it into a percent. 112%, because it makes sense. What would 100% would be one? One whole thing is 100%. So 1.12 is a little more than 100% of something. 112%. Kick ass. Now, real quick, 112% would not make sense in terms of probability, correct? If the probability of rain was 112%, what the hell? Is it going to rain so bad that the next universe gets rain too? Are the raindrops going to be big? Does anyone understand what I'm saying? 100% chance of rain is it's going to rain. 112% chance doesn't mean anything. This, though, does have meaning. Couldn't the price of something go up 112%? We all know this. Right? You with me? Okay, I like it. And now, two ways you can do a fraction. You can either do straight from here, 112 over 100, right? Isn't the percent mean per 100? So you could go directly from the percent, 112 over 100. There's another way to do it. You can write it as what? Mixed number. 1, there's the whole part, and 12 tenths, hundredths, right? These are the same, yes? Because how do you change from from mixed? Right, this is a mixed number. This is an improper fraction. How do you change from one to the other? 100 times 1 plus 12. Does anyone remember that? So you get 112 over 100. I like it. All right, now some of you guys are looking at me with eyes telling me, I don't know much of what you're talking about. So when you're working with these things, we're never going to do this directly. I just need you to feel more comfortable going between decimal and percent. There will sometimes be fractions. We will be using our calculator most of the time. So like if you had 3 divided by 7, you can just do it in the calculator and make it into a percentage. Are you guys with me? Okay. But I just want you to feel more comfortable by yourself with these things. Any questions on those problems? Okay. What about number 2? Who's got that? How do you do that? How do you set that one up? Class of 40 people, there are 5 left-handed people. Yes?
You do 5 over 40.
Beautiful. The mistake I always get is somebody tells me the answer is 8%. Because they know it's supposed to be 5 divided by 40, and somewhere the brain says, you can't divide 5 by 40, so turn it around. No, that doesn't make any sense. It's always part divided by whole, correct? So 5 over 40. You weren't allowed to use a calculator, and I want the answer as a percent.
0.5.
Yeah, so 5 over 40, you can make it 1/8 if you want to. There's a few ways to do this. Personally, here's my favorite way to do this, without a calculator. Everybody knows what 1/4 is as a decimal, yes? What's 1/4? 0.25, a quarter, right? 1/8 is half of 1/4, yes? So what's half of 25? So 0.25 is 1/4, 1/8 would be 0.125, just half of that, right? And then you can make that into a percent. Now there are other ways to do this. You can just long divide if you want to, for example. That's always exciting. Or I mean, never exciting, that's what I meant. How do you change that to a percent? 12.5%. Shebang. I like it. Okay. I like it. To remind you guys, again, I'm not going to make you long divide stuff. You can use your calculator. I just want us all to feel a little more comfortable working with this directly. 3 and 4, I think, gave us a lot of trouble for a lot of reasons. Even when you're taking algebra and you do equations that have no numbers in them, everybody freaks out a little bit. Just no numbers anywhere. The funny thing is, solving equations works if you have numbers or you don't. The process doesn't care. Number 3, the thing I'm trying to solve for is up here. So the worst thing about this equation is the fact that there's a fraction in it. The great thing about equations is I can kill things I don't like. This is not a life lesson. Math is okay because they don't feel it. As far as, oh man, I'm going to die, I'm going to go to hell, I'm going to have like variables coming up to me. You killed me so many times. Shit. Sorry, that was my own little trip I just took. Okay. So how do I kill a fraction in an equation?
Multiply by its inverse.
Yeah. Multiply by the denominator, even better. Because if I multiply by the inverse, I got more shit that's going to end up on the bottom, right? So isn't this side being divided by fat R? The real name is sigma, but fat people call it fat R. I like it. So anytime in an equation I've got a fraction, just multiply by the denominator, that fraction's gone. The equation will instantly look much better.
Well, you have to multiply the other side.
Beautiful. Whatever you do to one side of the equation, you got to do the other side, right? Otherwise, it's not a true equation anymore. So if I multiply this side by sigma, got to multiply this side by sigma. So then these cancel, die. So then I get z sigma equals x minus mu. That looks so much better already. It's one step away from having x by itself. What about the mu? Add it. I love it. It's being subtracted, so to undo it, I'm going to add it, and then I'll be done. Add mu, you get x equals mu plus z sigma. This is an actual statistics equation. This is an actual statistics equation. This is an actual statistics equation. So these are all things we're going to come back to later this semester. Right now, you don't have a freaking clue what some of this shit means, which is fine. I haven't told you yet. But math doesn't care. Math can handle variables. It doesn't matter what they mean. It can just mess with them. What's even worse about number 4? Yeah, there's a fraction and a square root, and the thing we're trying to solve for is underneath in a root. Shit. So does anybody have a suggestion as to what to do? We can do the first step we did over there, right? Yes. You could, yeah, okay. So we could square it right now. You have to square both sides, correct? Let's try that. So let's see if this is cool. Square this side, square this side. Now somebody help me out. What does that become? E squared equals z squared, sigma squared over n, right? The square and the square root cancel. Is that cool? Because they're opposites of each other. They kill each other. Lots of death. Okay, sorry. And now I'm like 2 steps away. The absolute worst thing, again, it's the same thing, but it's a little worse now. There's a fraction, but it's worse because our variable is on the bottom. So we can take care of that easy. What do we do when there's a fraction we don't want? Multiply by the thing making it a fraction. Then we'll multiply both sides by n. Let's do that first. multiply both sides by n. So I get ne squared equals die, z squared sigma squared. Then I'm one step away. How do we get n by itself? Yeah, this is n times mess. Let me divide by mess. So then I get n equals z squared sigma squared over e squared, which again is not just a fever dream of mine. It's an actual equation that we're going to use. All right, maybe. Okay. 5 and 6 are a little bit more like what we're going to do. And again, 3 and 4 is more algebra than we're going to do this semester, but you know, what the hell? I wanted to see how we felt about it. What about number 5? I mean, that one everybody should come in here knowing. How do you find the average of any set of numbers? Add them up, divide by how many there are. So what'd you get when you added all these up? 39 over 5. A little trick to divide by 5 if you don't have a calculator. Double the top and the bottom, because then you're divided by 10. Divided by 10, you just move the decimal back one. So division by 5 is easy. Double it, double the top, and move the decimal back once. Or some of you guys are like, no, I'll just use the thing we made, the calculator, whatever. You guys all with me? Now, real quick, what if our answer would have been 16? What if you got 16? How do you know that's wrong? Not just because the answer is 7.8. Let's say we got 16. How do you immediately know that's wrong?
That's not in the range.
Yeah, where should the mean show up? It should show up where in the set of data? Somewhere in the middle, right? 16 is bigger than the biggest. How could the average of those be bigger than all of them? So just quickly check to make sure it makes physical sense, your answer, right? I like it. Just like when somebody would tell me the length of the shed was -7 feet. Like, what did you make that out of? I don't want to go to your shed. I'm going to get sucked in. So some kind of weird black hole. All right. Don't make your stuff out of negative length wood, kids. Okay. What about number 6? I oversaw some people doing some good stuff. I think it was over here. Maybe I can't remember where it was. Who thinks they got the answer for number 6? Yes. What'd you do?
Just added 82 plus 71 plus x over 3 equals 80.
Okay, so let's break that down. If you have 3 numbers, how do you find their average? Add them up, divide by 3. Do I have 3 numbers? Math person would say yes. I have 82, I have 71, and I have x. Right? That's the trick of algebra. If you just could understand, algebra just says, let's pretend for a moment that we know this unknown thing. Let's call it x. And then we do shit to it that we would do if we knew what the number was. That is basically algebra. Right? You pretend like you know the answer, you do shit to it, and then you solve for it, and then you know the answer. Yay. So what I'm saying is, our 3 test grades are 82, 71, and x. So how do I find the average? Add them up, divide by the number of them, and you get the average. But we already know the average is 80, right? Now you solve it. We've already solved equations like this. What's the first step? Multiply by 3, right? To kill the fraction, die. So you get 82 plus 71 is 153 plus x equals 240. So then they went one step away, right? What do you do then? Subtract 153, and you get 87. Hello. Oops, sorry. I'm covering everything. Bless you. This is very strange light. There we go. So let me show you a little shortcut. Let me show you the way I would do this. So the way I would do that same problem is I would say, all right, I've got 82, 71, and something, right? How far is 82 away from 80? It's up 2. How far is 71 away from 80? Down 9. How far away from 80 am I total right now? Down 7, right? You guys see that? So then this should be up 7 from 80 to make the whole thing work out, and that's the answer, isn't it? Real quick, watch. What's the most basic set of 3 numbers that average to be 80? What's the most straightforward, three numbers that average to be 80. 80, 80, 80, correct? Isn't that kind of like the silly answer to it? 80, 80, 80. You with me? What's the average of this then? 80 still, because I took 2 away from that guy and I gave it to this guy, right? So they still all add up to be the same thing, don't they? So if I just see how far away from 80 everything is, I can just give this guy what he needs to average everybody out. Now again, did I say you have to do anything this way? No, we did the problem, didn't we? And it was fine, we got the right answer. I just want to show you a different way to think about it. If you're like, your way of thinking makes me hurt, then don't do it. It's fine. There's so many ways to do math, right? And what kills me is some of you guys had teachers that weren't flexible with you. You did it a different way. They said, it's not the way I showed you, when there was not a damn thing wrong with the way you did it. They could have explained the way you did it was great, but it's going to mess you up later. For this reason, this reason. That would have been great, but instead they say, no, you did it wrong. And then you kind of like, I hate math. I thought I understood it. Right? That's the worst thing in the world, and I'm sorry if that happened to you. I apologize on behalf of my profession. Okay, sorry, I'll shut up. So that's a little review, a little warm up. We're never gonna see something quite exactly like this problem, for example. We're not gonna see problems like this. We will see some algebra. You will have to work with decimals and percentages. You with me? So now is not the time to freak out. If you had any trouble with this, don't freak out. Okay, so if there's no other questions on that sheet, we're going to do a few definitions. What time we got? Okay, good. I want to let us out a little early, and I think I can still do that. The entire first chapter, I already told you this. It's almost as exciting as what we've been doing already. It's definitions. So, what I try to do to make it a little more interesting is I try to help you guys, help me, come up with a statistical study we might want to do. So let me give you kind of like a standard boring example of what I want from you right now. Can you focus, little dude? There you go, maybe. My poor phone is like, why did the math person have to buy me? He sees math all the time. It's going to become self-aware. So for example, let's say, here's a silly example. Let's say that we find out that 68% of Grossmont students, let me say it this way, like 30% of Grossmont students smoke, let's say, right? Or the average grade Grossmont students made in their classes last semester was 75 or something, right? You with me? Is there something you would be interested in knowing? A percentage of somebody that did some, of Grossmont students, or an average something or other of Grossmont students? Anything you would be interested in knowing? Anything? Or you guys are like, I don't want to know shit. I don't want to know anything. Anybody? Yes?
Percentage of Grossmont students that are nursing majors.
Okay, I love it. Okay. All right. Everybody with me? So he spoke up first. That's what we're doing. So if we want to figure out the percentage of Grossmont students who are nursing majors, and let's say for some reason we're not allowed to talk to the nursing staff. We go to them and they're like, we're too busy, get the hell away from us. What's our population in this example? Say again, sorry. I love it, okay. Let me make sure the distinction. Did they give me an eraser, which is like the most important thing in math, is an eraser. Does anybody see an eraser? Unbelievable. Okay, so let's see.
Your hand.
Huh?
Your hand.
My hand? Oh, my hand. I get you. That's my last resort, so I might have to go for it. I have that. That's a little scary. All right. Well, shit. Well, I am going home after this. It's all right. So I could just use the overhead.
You use your backpack?
Huh?
You use your backpack?
My backpack?
Like a
No.
eraser? It's
All right.
black.
Gotcha.
You want to use my bandana?
It's done. Thank you, though. Thank you. I appreciate it. Now, so one of the most basic statistics terminology, you all came in knowing two of them at least. Population, right? And a population, so if we're trying to study the percent of gross fund students who are nursing majors, our population is going to be all gross fund students. I want to really be clear real quick. If I ask you what the population is and you say gross fund students, next door, if I said next door, there's gross fund students next door. Can you guys envision that? There's gross fund students next door. What do you guys see in your head right now? Little group of gross fund students, right? What if I said all gross fund students are next door? Right now in my head, I have a horrifying scene of people just packed in. Like, why did we do this, right? Do you understand how there's a difference? If you don't say the word all, you're not showing me you understand what a population is. It should mean every damn thing that we're trying to say something about, right? So what I'm going to do is I'm going to write in black, I'm going to write the definition, and in blue I'm going to write the specific example. So for us, it would be all gross mod. God, it's weird. It's a little freaking shadow. Students. Can you guys see that all right? Now, reading it is a separate thing, because that's as good as I write, right? So if you want to be able to read your teacher wrote, you've chosen poorly. So that's our specific example, but the definition is the entire collection of elements or people we wish to describe. Would you guys agree that's what a population is? It's the whole group of everything we want to talk about. That's what the population is. Now, there used to be 20,000 gross fund students. Now there's about 11,000. Still, do you want to go talk to 11,000 gross fund students?
Sure.
Neither do I. You do? Samaj, go for it.
Okay.
Report to us tomorrow.
Hey, no.
No? Okay. So in statistics, obviously, what do we do? Because normally in statistics, the population is pretty damn big, right? So what do we do in statistics? Obviously, we take a sample, 11. So a sample, the definition, this definition is, I've taught 2 classes. I started my day at 7. A little tired. Okay. The sample is just a subgroup of the population. That's all a sample is. That's all it is. Now, why would you guys, are you guys a sample of gross fund students? Are you a good sample for the study we're talking about?
No.
Not because you're bad people. Why is this not a good sample?
Not large enough?
It's actually large enough, believe it or not. Larger is better, but this is large enough.
Not all of us are nursing.
That doesn't matter. If your sample was, if you made your sample only nursing majors, wouldn't the answer always be 100%? That wouldn't tell you a damn thing, right? Okay.
We're biased because we're the ones hypothetically conducting the
Okay, I see. I'm with you. But let's say that's not you. Let's say somebody else is conducting a survey and they pick this group. But I like that. You don't want to be a part of your own sample. That's definitely biased. Right, you guys with me? Now, why else would this be a bad sample? Oh, sorry.
It's not random.
Beautiful. Why is this not a random sample?
We're in a class, it may or may not be.
There's a reason you're all here, correct?
Yeah.
Anything that causes somebody to be eligible for your sample because the way you're picking could bias the results. Are there people that could never be in the sample I'm talking about if I'm using you guys? Yes. Does everybody have to take statistics? Is everybody able to take a class at this time? No. Is everybody able to come face to face? No. So there's a bunch of people, gross mod students, who would never be here, and they have 0 chance to get into the sample, correct? Does that make sense, though? So the official definition of random sample is one in which everything in the population has an equal chance to get into the sample. You guys with me? And that kind of makes sense. That's what we always strive for, is that. Because that would mean we're doing the work to make it as random as we can possibly make it. Right? If I pick my friends, that would be a bad sample, because they're my friends for a reason. We share similar ideas and so forth and whatever, right? Okay, maybe. So can somebody tell me what's a good sample to pick then? So let me start us off. What if I said I picked 5 people from every classroom on campus right now? Is that better than just you guys? Is that good yet?
No,
Why is that still bad?
online.
Because you're leaving out the online people, leaving out the people that can't come here at this time, we're leaving out the people that they never scheduled that kind of class at this time.
Like you could send out a survey to everyone.
Sure, we'd have to get
Yes or no?
addresses and such, which they might kind of balk at us,
Online.
right? So at some point though, we're gonna have to get a little unrealistic. So let's say this. Let's say I get a list of all Grossmont students. What could I then do? Yes? Beautiful. So if I pick a random person and then pick every 5th person after that. Everybody with me? So can you see the list? Can you see it? I pick a random person and then I take every 5th person after that. Does everybody have a chance to be in the sample? Now some people say no, and they say because this guy wasn't in the sample. That doesn't make any sense. Did he have a chance? Everybody had a chance. I picked the first person at random. So whoever's down here had a chance. It just depended on who I picked and then how far I went down. Everybody had a chance. You guys with me? I love it. And that actually is beautiful. That's called systematic. Every nth is called a systematic. We're going to come back to the methods of sampling. Don't worry. Another way to do it is just to tape the list to the wall and then start throwing darts or throwing a marker. And whoever I hit, that's in their sample, right? That's kind of like a truly random. There's no system to it, right? Are you guys all kind of with me? So we'll say our sample is like 500, doesn't really matter. 500 randomly selected Grossmont G-House students. Anybody still say G-House? I used to go to tennis games and stuff, saying it was G-House. No, okay. Grossmont students, sorry. Once we get them gathered, let's say we have them not in the room next door, that's cruel and unusual. We put them in a field, or we put them in a field. We put them out in the quad, 500 Grossmont students. What is our next thing we're gonna do? Remember, we're trying to figure out the percentage of Grossmont students who are nursing majors. Once we get our sample, what do we do immediately after that? Ask them a question. I love it. The name of the thing related to the question is the variable. The variable is related to the question we ask. What question will we ask these people? Well, yeah, we could ask them, what's your major? We could also ask them very specifically, are you a nursing major? So yeah, I love it. Both of those would get at this, wouldn't they? So let's just say, let's go with the first thing you said. We'll ask them, what's your major? So then the variable would be major, holy crap, Jeff. Major field of study. I should have put that in blue. Let me get my eraser out. Major field of study. It's not a question, but it's related to the question, right? The question would be, what's your major? So the variable is the major, the field of study, right? So again, we have a group you want to say something about. Ain't no way I could talk to all of them, so I pick a sample and then I ask them a question. All right, see how it's just flowing with what the shit we would do to figure out the answer to the question from the beginning. All right, as people answer, what are they giving? Give me some example answers.
Yes, no, yes,
No, remember, it's what's your major field of study? What's your major?
business.
Math, I love it. Business and blah, 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 blah. History, psychology. I almost made up a new word there. Kinesiology, whatever, right? You guys with me? Get a whole bunch of things. What is that called? When you just get all the answers to something. Data, kick ass. So variable is related to the question we ask. Data, is it Andrew? No, data is the answers to the question we ask, right? So in this case, the examples could be stuff like math, business, undecided, whatever, right? Art history. You all with me? Again, so it flows. Group we want to say something about, group we work with. We ask them a question, they give us answers. What do we do the minute we get the answers?
Analyze the data.
How exactly? I love it. We analyze the data.
Put it in a graph chart.
We're going to get 500 answers, right? Because we're not going to let them leave this field until they freaking answer a question, right? Can't go yet. I don't know. You're undecided. Okay, can I go? Yes, go ahead. You guys with me? So we're going to have 500 answers. Let's say that 50 of them say nursing. How would we analyze the data? We 50 divided by 500. We make a percentage, of course, right? And what's 50 divided by 500? 10%. I love it. So I'm going to skip one and go to 6. 6 is called the statistic. And all a statistic is a numerical description of a sample. I should have put something out here for like splash zone. I'm sorry. A statistic is a numerical description of a sample. There's a reason I'm doing this stuff, right? Numerical description of a sample. Statistic sample. So in this case, it would be 50 over 500 equals 10%. 10% are nursing majors, right? Now that's the sample, but that's our best guess for the population. That's how they come up with like polls, right? When they do voting polls and they say it looks like 40% are going to vote for this person. At the bottom, you always see plus or minus 4% or something, yes? Later this semester, we're going to learn the math behind where the shit that 4 comes from. They don't just pull it out there. Well, how sure are we? Plus or minus 5. Okay. No, there's an actual math equation that leads to that number. Bless you. So this one, so from the data, we can get the statistic. Does this answer the actual question directly? The actual question was, what's the percentage of all Grossman students who are nursing majors? So that is the thing we can't get, because that's the population, right? Most of the time we don't have the whole population. So that is the thing we're trying to get, and that is the parameter. A parameter is the same as this, except it's a numerical description of a population. You see that? Population. Let me face this way when I do that one. Parameter, population. You can't beat that. That doesn't happen often enough in math. You all understand. I'm sorry, I wrote really poorly. Parameter is a numerical description of a population. Same thing as this. These are both the same thing. They just talk about two different groups. One talks about the sample. One talks about the population. So if I said 83% of all stat students use Tylenol, is that a parameter or a statistic? I said all. I love it. If I said 28% of the 87 stat students I talked to liked the way that I taught definitions, is that a statistic or parameter? Because it's describing a sample. I love it. And now let me see how badly I lied. Oh, I didn't lie too bad, because I think that's where we'll stop. So we barely did section 1.1. You with me?
Will we be able to do like the first little blurb of homework?
Yes. You should actually be able to go further in the homework. It's just definitions. You can actually go back and read the section. Try to get ahead a little bit. Or not. It's up to you. If you need to see me, come up and see me. Otherwise, I'll see you guys Wednesday.